Alright, example 18. Given that fx is tangent x, show that f prime x is 1 plus fx squared. This one DIY, okay? Here they are DIY. Not difficult, just take 30 seconds. Can I have attention, please? Take 30 seconds to read through this, which is not difficult. It's going to differentiate tangent x, secant square is 1 plus tangent square is just fx, 1 plus fx squared, done. By repeated differentiation of this result. This question is quite explicit. They ask you to repeatedly differentiate this result, i.e. this one. Okay? Find the first two non-zero terms of the Maclaurin's expansion of fx. You're going to differentiate this result. How? In case some of us forget, f prime x actually is the same as dy dx. F double prime x is the same as d2y dx squared. So we must be comfortable with this notation as well as this notation. They are the same. Okay? Alright? So, I'm going to differentiate this result. Differentiate 1. Differentiate 1, I get 0. Differentiate fx squared. That means I'm actually differentiating dy dx squared. How? You bring the 2 down. Alright, you get 2 fx. Correct? And then chain rule tells us you've got to differentiate fx once. Got it? Yes? You're doing tutorial 8 now, right? You should be familiar. Bring the 2 down. 2fx times differentiate fx once, which is f prime x. F prime x. All okay? All okay? Now, let's look at a question. Repeat the differentiation. Okay, we're going to then we're going to differentiate this one more time. How do we differentiate this? Be careful, okay? Okay, why don't... No, I do. If I let you all do, maybe take a long time. Okay, let's do this. Okay? This is made up of a product of two functions. This one and this one. You got to use product rule. Okay? You have this as well as this. You got to use product rule. Okay? Alright? So, you keep 2fx, you differentiate f prime x, you get f double prime x, plus you differentiate 2fx, get 2f prime x, and keep the f prime x, you get remain f prime x. If we can simplify this a little bit, it's actually 2fx f double prime x plus 2f prime x. I would like us to look at how I write this, okay? It is put square bracket outside and then put a square here, okay? Put square bracket and put a square here. Don't be lazy, so that you know exactly what is happening. It is fx times f prime x times f prime x. So it's f prime x squared. All right. Now we're going to then find the Maclaurin's expansion of fx. Okay, let us take a look again. I always copy and paste this here because this is from a formula list. Don't have to memorize. Okay? Wait, I create some space first, okay? This is the value of fx at x equals to 0. Correct? This one is the value of f prime x at x equals to 0. So we're going to find all these values using what? Using this expression. Using this one. Now, obviously when x is 0, we can easily substitute. We get f0 is tangent 0. What is it? Hey, move leh. It's moving. Tangent 0. Correct? All good? All can understand that? No problem. We substitute 0 in, you get tangent 0. Now f prime 0. Many of us would be very tempted to look at this because you all are very comfortable. You substitute x into this, you get 1 plus tangent 0, tangent square 0, which is not wrong. Which is really not wrong. In the end, you will get f prime 0, you will get 1. Entirely correct. But I'm going to use this result instead. Can I? I'm just going to say that at x equals to 0, here, hey, I'm going to say this, I'm going to say it, I'm not going to write, okay? You all pay attention, okay? At x equals to 0, I know f0 is 0. So I'm going to say this is 0. Because I know f0 is 0. Correct? Then I get 1 plus 0. I will still get 1. You know what I'm saying? I don't substitute x to 0 directly to this. I substitute x to 0 here. Of course, I will get the same thing. Because I know at x equals to 0, f0 is 0. So I'm going to write this like that. Using the same idea, can I find f double prime 0? I substitute 0 here, I sub 0 in, I will get something. Oh, sorry, it's 1. What am I talking about? Stupid, Actually, math teachers can be quite stupid sometimes. Okay, yeah. Now, f double prime 0, you're going to substitute 0 in, 0 in. I think you all can evaluate this out. Get 2 f0 f prime 0. In the end, you get 0. And lastly, you substitute into this one. You get 2 f0 f double prime 0 plus 2 f prime 0 squared. Now, f0 is 0, so this one goes. F prime 0 is 1, so you get 2 times 1, you get 2. So tedious. Yeah, quite tedious, but it's okay. Now we refer to the formula list. We have gotten all these coefficients out. Because now I know this one is 0, this one is 0, this one is 1, and then this is 2, whatever here is 2. So I'm going to substitute, I get 0 plus x times 1 plus x squared over 2 factorial times 0 plus x cubed over 3 factorial times 2 plus total. You know how I got this term or not? You know, right? C pattern, right? Anyway, this is given the formula list. x square, x cubed not given, but you all must know it will be x cubed over 3 factorial times f triple prime 0. Follow? Yes? Very dry, right? Aiyo, so boring. Okay. Let's look back at the question. Now, the question then, the last part of the question requires us, to hence find the first two non-zero terms of secant square x. Things ask, how do I do it? How do I do it? You actually found the can I have attention? You actually found the Maclaurin's expansion for tangent x. Correct? You actually found the Maclaurin's expansion for tangent x. You got to find the link between tangent x and secant square x. The most obvious link is you differentiate tangent x is actually secant square x. Now differentiate tangent x is secant square x. Now you already found the Maclaurin's expansion for tangent x. You're just going to substitute the one above here and differentiate one time again. All got it. All printed for you. Are you okay? Okay? Good? Very good. Okay. Example 19. Okay? I know it's a bit dry, but never mind. Aiya. By now you all know already, it's not difficult. Correct? Okay? But we still have to do, no choice.